And we're live. Welcome back to another Corona Geek, where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever. And today, we're going to continue our conversation about 2D shadows and using gravity in games. This is going to be a brand new conversation that we're going to start this week. And if you haven't already checked out last week's conversation, we talked about 2D math, issues that can kind of come up when you're using custom shaders. And we also kind of hinted at the 2D shadows solution that we're going to look at some code for today. I'm not sure if that sentence actually makes sense, but you get the point. So joining us on the panel is Dr. Brian Burton down in Abilene.
Hello. You
can find his stuff over at burtonsmediagroup.com. Also joining us is Ed Maurina from roaminggamer.com.
Howdy.
Got our Jason Schroeder from jasonschroeder.com, rocking the personalized domain. Laura Talarde. Laura, where are you these days?
I'm in Brooklyn.
No, your domain. Where can people find you online?
LauraTalarde.com.
LauraTalarde.com. So you're also rocking the personal domain. I have there's a whole conversation we could have on that. I'm really interested in how people choose their brands. But we'll have to save that for tomorrow night at the Corona Geek After Dark. And also joining us from Xibalba Studios is Stephen Johnson. I think I said that right, but I don't know. So, yeah, if you guys haven't had a chance, go back to youtube.com/Corona Geek. We have all our videos there. You can catch everything that's there. Ed's done some videos, from follow-up videos to last week's conversation. We've also got a new series going on, Corona Geek After Dark, where we meet every Tuesday night at 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern, and we talk about all things either app development or community related or just general geek foo is what I'm somewhere between geekery and geek foo. I'm not sure exactly which term I like better, but they both sound fun. So that's what we're.
Or insulting me.
What's up? Where what?
Or occasionally insulting me.
Oh yeah, we definitely, it's definitely
I know.
Punch and bag Ed. No, Ed brings up a bunch of great topics and it gets everybody excited and we all want to talk about it and then Ed's like, well, let's not talk about my topic. So it's your own fault, man. You spin it up and then we're all over it like chihuahuas on a pork chop and then the problem is you're the pork chop.
Chihuahuas, I like that.
You can be the Chihuahua if you want. I don't care.
You definitely.
Some days you're the Chihuahua, some days you're the pork chop.
Some days you're the Chihuahua, some days you're the pork chop. That is a T-shirt, my friend. That is a T-shirt. That is like Confucius say. All right, enough of that. We do that on Tuesday night. What we're going to do here today is look at code. We're all about, the mechanics and the code and the technical stuff here. So let's talk about 2D shadows. Now, Stephen, you last week showed us an example of a 2D shadow / custom shader example, and we didn't have enough time to get to the code, but you got that for us today, right?
Yep.
Sweet.
To recap, it was this. And this is visible?
Yes.
Okay.
There's a green spring thing.
There was a conversation on the forum where somebody was asking how to put a shadow oriented in a given direction underneath an object. It would basically respect the direction of the light source. And the shader isn't so much necessary for that, but I realized, hey, I could use this to demonstrate multipaths. So what this is doing is using the Gaussian blur effect, which is a built-in Corona effect. And then after that, it's applying another effect on top of that.
Okay, so for the home listeners who can't see this, it's basically a coil spring with a rotating light source and
the spring itself is rotating.
Yeah, and the spring itself is rotating, and the shadows have been colorized in some manner so that you can see them better. And as everything kind of spins around each other, the shadow offsets either way depending on where the light source is.
Right. It's taking basically the relative angle between the spring's angle and the light angle.
Right. That's the technical version. The dot thingy is going around the spring thingy. Got it.
Right. And as others have said, the Gaussian blur doesn't seem to be all that fast on a device. So this is more of an illustrative example, but I haven't had a chance to run some other multipass effects through their paces. So I don't know if that's a general multipass thing or if it's particular to Gaussian blur. But in this case, you could pre-compute that and save it, and then just shift the shadow. Let's see. So it begins as a normal rectangle. This is adapted from some code on the Code Exchange by Horace Bury. I think he's Matt Webster. Not quite sure on that.
Yeah.
Okay. So he had something where you could create a drop shadow by essentially creating a slightly larger version of your image with, let's see if it's, that was all black. And then you would apply the Gaussian blur to that, and then capture. There's a capture involved.
Gotcha. And this is kind of an old school throwback to when graphic tools didn't really have a built-in shadow effect. People would do that. They would copy things, put it on a different layer, change its alpha or whatnot, and then create this pseudo shadow effect on their text or their image or their whatever, right?
Yep. And it's nice to use the effect itself because you don't have to make all the assets by hand. But it's just, at the same time, you run up against the issue with the slowness.
So in this solution, that it is in fact kind of making the copy programmatically and then applying the filter and stuff. So you're not, like you said, you're not creating image assets, but you're getting the same net effect.
Right.
Okay. Cool.
And here we see where it's setting some of the effect parameters, and already you see that this part looks like what you would see setting the Gaussian fields. These are all those same parameters. And then here, instead of the prefix blur, we have the prefix move, which is like moving the shadow with a subfield, light angle. And it's rotated in an enter frame handler. So that's the object itself has a standard rotation, as does the underlying shadow. And each frame we update the angle of the shadow based on what the two angles look like in comparison to each other. So that's just to account for both rotations going on at once.
Let me ask you, I see there's some cosine stuff going on there and some sine stuff going on there. So, like math.cos and math.sine. Do you feel like this is something that you can reference in a book? Like if I wanted to do this kind of stuff, could I reference it in a book and just kind of copy and paste the concepts, or would I have to understand the math, or what's the best way to do that?
The only thing that's doing is moving the light. So it's just a circle equation, basically. So center x, center y, radius, and then these are the two parts of the angle. So you basically just look up the equation for a circle.
And so this could be, you could say this is sort of language independent, right? I mean, it's not necessarily, I mean, again, the math library there is probably pretty generic, so it's just,
yeah.
Okay, so you could just look it up, Google it, so to speak, and then pop it into your code, and then maybe massage it to be language specific.
Yeah, and I suppose you could I was going to say you could just anchor some point, but then you can't go outside of the object. Otherwise, you could just update the rotation of the light. But
yeah, I just know that took half a semester of high school trig,
right?
Like a bazillion years ago. So when I see that, I'm like, oh, I know what that is. I know enough to know that I don't know how to do that, but I do recognize it for what it is.
Right. Well, the cosine, it looks like x divided by r. So you're multiplying that by an r, and the r's sort of cancel, and you get an x back out of that. I don't know if that's very intuitive, but that's one way to see which things should line up. So this is the multipass effect, the code for it. It looks like a normal kernel up to this point, where you say what kind it is. It's one using a texture. Well, I guess it's not even using a texture, but and it has, you give it a name. And this is the difference between a normal kernel as we've seen so far, a shader that we've seen, and a multipass. Here we have nodes, which say the steps in the process. You tell it what the final step should be, so that's your output. And then at each step along the way, you tell it what effect it's referencing. In this case, it's using the built-in blur Gaussian, where the input should be coming from. And we do the same thing here. This is using, in effect, we define up above. And the input is coming from the previous pass. So this will be a two-step effect. And actually, I think it's a four-step effect because Gaussian is doing the same thing under the hood. It's using horizontal filter followed by a vertical filter. So you can really compose these quite a bit.
Would it be fair to say that if you understood the combined effects of different, I'm trying to say this right, if you understood the performance or the combined effects of something, would that affect your decision as to how to combine the different effects? I don't know if that makes sense. You know what I'm saying? Like you're saying that there's maybe some overlap there. Is there a way to like look at something and say, oh, well, I don't want to definitely combine these two things because they're duplicating effort?
Right. I think. So I don't know what decisions they made when they wrote Gaussian. I think it's what's called a separable filter, so it can be broken up into two steps. And maybe they just did it because they didn't want to do the work twice. Or maybe it was just because it's a little easier to write separately and then put them together. But definitely, if you knew something was fairly inexpensive, then it would be a no-brainer. Just use what you already have, so you don't have to rewrite it.
Yeah, I mean, it's, you see these types of things in other data processing, right, where you maybe pull back a bunch of records from the database, and then you have them, and then you kind of unpack them, but you don't want to necessarily have to flip through them again because you've already done that once, right? So you just sort of look for ways to be more efficient.
Like Etta has said, I'm lazy, I don't want to do it again. It's the same thing in shaders.
Okay.
So finally, this is the vertex is what's shifting the position around, and I didn't have to, but I baked in the size. I was experimenting with some other things that would have required more input, and they didn't work. So I still have this, which is like in the glass example where you have a hard-coded size. They combine into a string and then get baked. And like before, this is just finding, instead of the position on a circle, it's the direction from the center. So basically, subtracting the position on the circle from the center to figure out a direction, and shifting a little bit in that direction. And then I said, well, you could do that on the Lua side, so it's not really that impressive. And I'll just add some color in. That's why it's glowing like that. So there is something in GL that lets you get the screen coordinates, and I just scaled those by the size of a pixel, basically. So the screen position is being used to calculate the color, and it actually remains fixed as this is rotating, but there's a little blinking going on too from the angle.
So you just said something that I want to highlight since we're kind of right there. you said that you could accomplish that in Lua, so that that piece wasn't all that impressive. So correct me if I'm wrong if I say that the starting point on these types of things would be to go and look at the built-in filters that are already provided in Lua. I mean, in Corona.
Right.
And then say, does this do what I want to do? And then look at, okay, well, how do I modify something like this in Lua to do what I want to do? And then if you further can't accomplish what you want to do, then you would wind up getting into some of this more advanced stuff. I don't even know if that's advanced is the right, but some of this more core stuff to shaders to be able to accomplish what you want to accomplish.
Right. If all you needed to do was move the shadow around a little bit each frame, then this isn't very demanding. It's just that you literally just move the position. So, but and I realized that as I was somewhere midway through, and I said, okay, well, if I'm gonna, I should probably add a little more to this just to show.
But I think that's a good concept to grasp onto, is that there's like you've talked about before. There's the shader specific things that are common across all different platforms, right? All SDKs, all different languages, all different whatevers, right? There's just those concepts that are just shader concepts, and then there's more specific concepts that are like, how does Corona implement this, and what options do I have to be able to tweak, sort of thing. So
right. So there's that, and there's do I even need a shader? Can I do this with Graphics 2.0 already, or when do you need to take the plunge? And it's at some point it's just you get a feel for it. I don't know if there's any hard and fast rules, but
there's no flow chart that says if this then that.
Not that I can think of, no.
Hey, Steven, could you
Yes.
share your code again, please?
Oh, sure.
Now that you did.
Here.
You're the waitress that just, hey, how's your meal?
Can I take your plate?
Mhm.
Okay, what are we looking
Okay,
at?
on line. Okay, whoa, stop flipping. All right, on line 46.
Okay.
Percent, that bit right there. Where? How did that? What is that? That's not Lua.
That is Lua. Okay, this is unrelated to shaders, but
This looks backwards to me. It looks like a
The-
string format call with no string.
it is a string format call. It's the string table, or the string type has a meta table. A few years back, somebody named Joshua Jensen, he posted to the Lua mailing list, hey, I have my own branch of Lua and I added meta tables on types,
Mhm.
and I found it really useful. And they accepted this into Lua. So every type can have a meta table, except for tables, because they have individual meta tables. And strings have built in as a meta table the string library. So you can call methods from the string library on a string.
Okay.
And the parentheses are necessary because of the Lua grammar.
Wow.
Because the way
It's blowing my mind, though.
So basically, it's just a string dot format with
I gotta try this.
first argument and this is second argument. So
There you go,
Oh,
Ed.
where am I
There's
using it? I don't know.
there is something to blow apart your whole week.
Yeah, that's the problem with this Hangout. I always get stuff from you guys. I'm like, oh, good, that's interesting. I'll go look at that. What was I supposed to do? I don't remember, but I'm gonna go look at that thing now.
and the
thanks.
percent dot two is just 2 decimal places. So that's just a
Yeah, I mean, I understand that. I understand it's just that the order in which I'm seeing the code is very bizarre to me.
okay.
Yeah, because you can see it's just concatenating that together and then concatenating on the other end, and but the other piece is confusing. Yeah, I figured it. I figured everybody else understood it except for me, so I didn't say anything.
Any other questions on this, or
No?
Yeah, anybody on the panel got a question? Yeah. Oh.
Right.
All right. Barry's out. Barry's
Had no
Barry's here.
question, so drop himself.
Yeah, right.
We'll pop back once it's done.
Okay,
Something
well-
for his lunch.
Well, excellent. Did you say you have some shader examples or some links that you want to share with us?
The same repository I used in the way back in the coroutines example. I've added another directory for shaders in there. So
Okay.
I do have most, if not all of them, in there. All my links are right now in a text file, so they're not very pretty, but they're there.
Okay. All right. Well, we'll link to that in the show notes. So if you guys are interested in seeing and getting access to the code that Stephen was showing us, then you can download that there. So check the show notes. All right. Let's talk about. Thank you, Stephen, for that. That's excellent. I mean, like I said, we've been building on this concept as we've gone along, right? And we've said this before, that when we first started out, it was kind of like, yeah, shaders. What are they? What can you do with them? Now, we're kind of up to this point where we're like, hey, look, here's some 2D shadow examples and things like that. So if you've been following along in the conversation, it will become more and more, I don't know if more and more easier is there a correct term? It'll become easier to kind of get what's going on here. So if you haven't, go back to youtube.com/Corona Geek. Check out, I think, starting with maybe 150 or 149 or somewhere in there. We started talking about shaders, so go check that out. All right, Ed's making a face. His eyebrows are almost off of his forehead. What are you doing?
Not making a face.
Oh, it stopped. The thing froze. I love the way Google Hangouts. It always freezes at like that moment, like the People Magazine moment.
Can you see my camera?
Yeah.
Okay, I was trying to share my screen. It hangs sometimes when you share your screen.
That's the hang part of Hangout.
Yeah. Okay. Can you see my screen?
Yes.
Okay. Excellent. So today, what we're supposed to be talking about, on my part, what I'm supposed to be talking about, is gravity and using it in your games. And as I like to choose a game that we may or may not know, but a good game that can demonstrate the principle, so we have something to talk to. Just a minute, I have to cough.
Did you guys watch the review for this? Is this the one, Ed, that I had in the trailer? The review for this?
That was the Lonnie Doss review.
That guy's hilarious.
He's a young man who makes his living doing game reviews.
He's hilarious. He's funny. Very funny.
He's funny. Yeah. It's all the same jokes after about a couple dozen videos, but he still does a good review of the game, so I still watch him. But hopefully he's not gonna watch this and go, "Well, I will never be reviewing your game now that you made fun of my jokes." But good job. Dang it. Anyways, I did see this game on one of his review videos some time ago, and I was quite impressed because it's one of those games and you look at it and you see how it's played and you say, wow, one, I'm sure I could have made that. Two, why didn't I make that? Because now this guy's making a bundle of dough and people are downloading it for whatever your motivation is. We won't go into the monetization thing again. The evil word of the week, month, that is. The point is that I was impressed with this game, and then interestingly, as I went along, I saw, version 1, version 2, version 3. This game now has 3 versions. All of them use the same basic core mechanic. I suppose, start the video before I look at my own stuff. So what this is a game implementing localized gravity. And in the game, you're this little dude, and you run around and jump on these things, avoid the spikes, avoid other active elements. You pick up gems, and then you jump in the mouth of this monster here and deliver the gems. So it's kind of a funny ending to the whole thing. So what we're going to talk about today is the beginning of a re-implementation of this game, in the sense that we are going to look at how to do localized gravity. So I don't need to keep showing any of that. Let me just bring up, so like we did for the game Zig Zag Boom, I put together a little document that is going to be in the repository that you can download for this talk. And in this, in the stuff that you get to download is a little PDF where I go over the, sort of like break down the game. I'm sorry, I've still got this cough.
Well, you made a template, gear hopper or whatever, gear jumper, and this kind of reminds me of that kind of stuff, being able to hop from thing to thing. But I'm really interested in how we're going to walk around the edges of corners.
Yeah, so I can compare this to that in a minute, just to give you the differences, some of the differences. But it's similar in the I mean, we were talking about this before the show, but if you've seen games for the past 10 years, you've pretty much seen every mechanic under the sun. It's just a question of how people combine them and spruce them up a little bit, make them a little more juicy, give them their own look and feel. But there's only so many things you can do. In this game, like I said, it's the basic mechanic is just you running around things and getting attracted to them and jumping from one block to the next. And so in the game, they need to be fed, which is what we're going to make sort of a copy of. It's a platformer with dynamic gravity. That's it in a nutshell. The game ends when you touch a spike or some other thing that can kill you, or if you deliver your gems to the hungry monsters at the end of the level. You earn points for delivering more gems. One thing that's interesting that we'll get into later, not today, is the game implements sub-level or level, how do I say it? Probably sub-level checkpoints. So it's a game that progresses from level to level. Each level is tight and has a very small area in which you have to do your jumping and figuring out the puzzles. But I think they realized that even then people got stuck, because this is one of those games where you can just keep dying and then go back and play again. And so instead of having people start over from the beginning of the level every time, they have checkpoints. In fact, I don't think I showed that. Let's see if the video is still playing. Here's one right there. So we're going to see this guy jumping, and this little doohickey right here, I don't know if you can see it, he's going to run there.
I think we're still seeing your summary.
Can you see it?
I'm still seeing your summary.
I'm seeing video. So.
Oh, you're seeing the video. Okay, go ahead.
Okay. So he's going to run around here, and we see that the little dot filled in. That means that that checkpoint has been set. Now, if he dies by jumping on these spikes on the right side, he'll restart at the checkpoint.
Oh, thank you for explaining that, because I didn't know what that was. I played it, but I was like, oh, I got the little dot. I don't know what that means.
Yeah, so it's you don't know what it is until you need it, and you're like, oh, cool. I don't have to go all the way back. So we're not going to implement that this week, but we'll definitely do it in a future show, Hangout. Because this week, what I really want to focus on is just the core mechanic, which is the gravity, localized gravity. But I got to run you through some of the other details so it kind of makes sense. So what else is in here? Like I said, sequentially connected levels. It's just a level-to-level thing. You have level 1, level 2, and the checkpoints, so you don't have to do them all. Long list of mechanics. We're not going to go over it all, but basically it's a little dude who can run around left and right, and he can jump. He stays oriented to his current gravity source, so his feet stay pointed at whatever he's attracted to. What else? Whoops. The world. Non-parallax. It's a simple background. It's one layer. It doesn't have multiple layers.
Although I think parallax would make a nice, interesting addition to the whole moving, right? I mean, just having things kind of slide as you slide.
Yeah, I mean, if you wanted to make a game like this, but then give it your own look and feel, you could. You could add parallax and give it a little more depth concept or feeling.
Right.
The level's made up of things like circles and squirrels, basic squirrels, squares, basic shapes. Which is another thing that I thought was brilliant when I first saw the game. I'm like, this guy just took basic shapes and he made them sexy. Gave them little feels and movements and things, cool things they do. Spikes and other stationary threats. And then there's turrets that you would see if you play the game a little bit further that shoot missiles at you. Another thing is I'm taking and sort of like mashing together all three games because I've seen them all and I kind of forget which one's which. So if you play some of the earlier versions of this game, you'll be like, hey, I don't see any missiles in here. Maybe there were no missiles in one, but I know that in one of the three games that there are missiles. Monsters, that changes from game to game. The first game, it's monsters. I think the second game, it's like these plants that you have to climb to deliver, but they're monsters. The checkpoints we talked about, and gems.
Hey, Ed.
Yeah.
As you were talking, I was thinking about you're talking about these basic shapes, these squares, circles, things like that. I don't think that it happens, but when the character jumps from shape to shape, it would be kind of interesting. I'm not saying we have to do it for the example here, but as an exercise for the listener, if they wanted to make the shapes sort of pulsate or shake when the character goes from shape to shape, I think that would be a nice little addition too, right? So
Yeah,
give it sort of an organic
you're
feel.
talking about there's a mechanic in here when you jump on the circular shapes and maybe some of the other ones where they bobble a little bit, like when you hit them, they move, and then when you jump off they move, to give you this juicy feeling of they're springy.
Yeah. Yeah, it seems like that's a missing piece from a lot of games. Is just to go sort of give it more of an organic feel.
Right. Yeah, I really like that. You know, the whole juicy topic concept came out of a talk several years back, but I really identified it with it because the guys, when they said it, as soon as I heard juicy, I'm like, yeah, that's exactly the description of all that extra stuff that you do to make the game more visceral, to make it sort of like engage the user.
Is that the talk where the guy took the exact same game he started off with? He's like, hey, it's a platform shooter, and then he went through and added all these different pieces to it.
Beer.
Yeah, and then by the end you're like that's an awesome game, but it was the same game he started out with.
It was the same game, exactly right. I think there were two different versions of this talk. One version they did with a game like Breakout, and another version they did with a platformer. But the concept was the same. They took a very boring game, and then they started to add little extra bits to it using their rule set of add this, do that, make the guns bigger, more bullets, make the world shake, make the camera shake, make the bullets stick around, stuff like that. And you're like, that game went from really super boring to where can I get it?
Right. Yeah.
And it's still the same game.
Yeah.
So let me just finish off this list here and we can get into the interesting bits. So the only other thing that's really important is the camera. It's a standard center tracking camera that basically tracks the character and keeps it in the middle of the screen. Now, it may be a bit hard to see in this video, but this camera keeps the character in the middle of the screen, but it lags the character a little bit. We're not going to do that initially. Initially, our camera is going to be fixed in the sense that the character always stays perfectly in the center of the screen. Making the character be able to get ahead of the camera or having the camera lag is actually it's trickier to show people how that works. There's that bit with the bubbles and how they move around. In addition, these ones that he jumps on that have got the little thing in the middle, they're timed and they get destroyed after a certain period of time, so you can only use them for so long. Anyway, let's get out of there. That's all entertaining and whatnot, but let me see. Unlike the previous time when we did the I Can Make That for Zig Zag Boom, my focus is going to be entirely on making the mechanics. And so we're going to make the play GUI, which is the part where you play the game, and none of the rest. Now, I may later package this up in a little template and let people download it with a composer template that has a main menu and stuff. But we're not even going to talk about that because it's sort of like once you've done it, you don't need to redo it. And this code is so simple that you'll be able to insert it into your own framework if you wish to take it from there and extend it.
Yeah, so there you go. If you're interested in that sort of thing, then go back and watch the Zig Zag Boom video. And
that template there will pretty much apply to this. I mean, I've changed some of the bits. So the only thing I want to talk about before I get into actually looking at the demo and the code is just where stuff exists. So you can get this on the GitHub, as always. The link will be provided with the show, and you can download a zip file that contains everything. And you'll be able to just go and get a new copy of that zip file after every show, and it'll have the latest stuff in it. Or you can go and grab my whole Corona Geek repository and keep that up to date on your local machine. Within here, the only folder that we really care about, and it didn't come out highlighted, I went through all this trouble to highlight it, it didn't highlight, is the app folder. There's an app old versions, so as I talk about stuff on the show, the Hangout, I'll be talking to one version of the game, and then I may make changes for the next version of the game, but I will put that day's copy in the backup folder, the app old versions. And I'll mark them in such a way with the dates you can go, oh, that was for that show. Then you'll know that's the code I was talking to that time on the Hangout, because the final version is certainly not going to match what we're talking about today, because it will get progressively more complex and have more features added to it. So app, that's where you want to go, and app game specifically to look at the source code. Within... Oh, I see what I did. I have another copy of it. Nicely formatted. Okay, so app game, that's what you're looking for. And then the game file itself, app game, has your basic build settings file, config Lua, main Lua, which is one of the files we care about, which is the entry point for all standard Corona apps. A folder called data, which contains what I call level layout definitions. I'll talk about that in a minute. An images folder, which we really don't care about, but it's going to have some demo art in it from a free art pack that we'll use. It's not being applied right now, but in future versions of this game, as we talk about it, the art will get better, and it'll be from this folder here. Okay, another big folder that you're going to want to dig into is, and we're going to be looking at all this stuff, is the scripts folder. And under there is common Lua, which is it's my grab bag for all kinds of settings and variables that I'm going to use throughout all the other scripts. Instead of using globals, I put them all in a module, so I'm using modular. I'm quoting the screen like you can see me. Modular design is described in a blog post by, I think, Rob or Brent. Inputs Lua, which is a very small module whose whole job it is to put 3 buttons on the screen for going left, going right, and jumping. And, oh, I left one out, game Lua, that is the game code itself. I'll put that in here. And then level loader Lua, which is we should take a little break here, and I will describe one facet of this game that I think people will find useful and interesting, but then we will not talk about it again until a future show. As you may know, I approach different games in different ways. Sometimes I like to make little editors, and sometimes I like to make little custom level loaders. And so in this case, I made a custom level loader that takes, let me see if I can show you here, takes a file like this. First of all, I decided that the levels in this game demo that I'm doing for the Hangout would always consist of a maximum of an 8x8 grid of objects laid out on the screen. So at maximum, you can have 64 jumping bits, places where you can jump and land. And then you can have one player, and then you'll be able to have gems and spikes and stuff like that. But the major elements, 64 laid out in an 8x8 grid. And then what I wanted to do was make it really super, super simple to construct these without having to do any dragging and dropping or setting up the coordinates or anything like that. So what I did was, and again, I'm just going to breeze through this now, and we'll give this a deeper look later, is I create these files, and the file's whole job is to return a table that has just a whole bunch of entries, 64 entries, which I've organized on the screen in an 8x8 grid, but you can see that basically this is just going to be 1, 2, all the way to 8, 9, 10, 11, up to 64. And then level loader, I'll come back to this in a minute, but level loader is a much more complicated looking piece of code, and what it does is it reads that table, that simple one that we were looking at, and then it converts each entry into a more complex subtable that tells it like X and Y position, what kind of object is supposed to go there, and other details. But when we're designing our levels, all we need to do is say, I want the player to start at this position, so that's the SS symbol, and I've only got 3 builder types right now. Then I want a circle on the right, and I want a square on the left. And if we do that, we get a level like this in the end. Let me reload it. We get a level that looks like this. Circle in the middle with our character on it, because that's the starting object. A circle on the right, just like we specified right here. And a square on the left. And then if I wanted to quickly just modify this level, I could add some more stuff in here. So boom, boom, reload, and now I've got more bits in my game. And so I did this because I thought it was going to be accessible to people, and because I thought this is a really great way to teach people to make their game levels and to show you that you do not need to use external editors. If you just think in advance how your game's going to be laid out, you can come up with a technique that's going to let you make the content very rapidly for your game, especially when it's a fixed grid system like this, where everything has to lay on a grid. Okay, so like I said, I want to. This show is really going to be about me rushing through 90% of the content with the promise that on a future Hangout we're going to come back because I want to jump into the gravity bits. But let me take you through a tour of what you're going to see. When you get this, the level will look something like this. Whatever I end up saving in this file will be here. And the way our game works, in a nutshell, before we look at the actual gravity code, it's very, very simple. We have a circle here, which is our player, and I'm going to turn on some debug features in just a minute so you can see things more clearly. And then we have circles and squares. Now the big circles and the big squares are the things that we jump on and we run around, and the little circle is our character. In fact, let me turn on the debug features. If you go into Common Lua, at the top there is a flag called Debug Enable. If you set that to true, reload the project, what you're going to get is it will show you everything that was there before, and the green object is the current attractor. It's the object that is our gravity source, in a sense. Whereas anything yellow is not attracting us. Furthermore, there's an arrow on our player that shows the direction that gravity is pointing. So at this point it's pointing down, but if I were to run around the character, now gravity is pointing sort of up and to the left. These little red numbers here tell us how far away the character is from that object. And the rule of thumb is, what we do is when we create the level, I put all of the attractors, all the possible attractors, which are these level bits, in a table. And then I, every frame, iterate over the table, and I say how far away is that object from the player. And then I store that distance right in a field on the object. And then when I get done with that, I sort the table based on nearest to furthest. And so the nearest object will always be the first entry in the table, the second nearest will be the next object in the table, and so on and so forth. Now the reason I did this was because although we're doing a simplified gravity model in which only one object is contributing our localized gravity, if I wanted to make this a much more complex and interesting example or start to change it into a different game, I could theoretically say the closest 3 objects all apply a force. And then we would get this much more interesting gravity situation where you're getting pulled by multiple objects and it could change the feel of the game. But in this case, the nearest object is our gravity source. And I'll get to what it means to be a gravity source in a minute. The only other thing that you need to know about this example right now is that the way movement works, okay, so we have a force that pushes our object in the direction of the red arrow, which is our gravity, our personal gravity. And then I'm utilizing, now I'm sure that this is not how they did this when they implemented the game, the original game, but it's my rule that I look at a game that I want to duplicate the mechanics of, and I say, what tools do I have in my toolbox that will make it easy for me to reproduce that mechanic? So in other words, I don't have to do it the way they did it. One, I don't know how they did it because I never saw their code, but I can guess. And so what I said was, I'm going to use physics to move my character and push it into other objects to have a personal gravity. And then I'm also going to use friction to do the movement. So what you don't see here is that when I push the left arrow, this character, this object here spins. And it has a high friction, and because it's in contact with this circle, which also has friction, that causes it to want to move in this direction. It actually pushes it. So it's spinning counterclockwise. And it's pushing on this static body here, and it simply pushes it around. So a force is pushing it into the object, and then another force, which is friction, is causing it to move around the object. So I cheated. I just used real basic, simple built-in feature of Box2D, which is used by Corona, to implement movement. And the only other thing I have left then to do is jumping. So when I click on this button,
So Ed, just
yeah.
for the imagination of the viewer, if you were envisioning a character with their feet on the bottom and their head at the top,
Right.
right, then their feet would always be planted to the object.
Right.
Because
We're
they
going to
would-
replace this, all this stuff you're seeing in a future installment with some artwork. But I wanted to first ground people in the concept of the direction in which the force is moving, the distance, the objects, who is my attractor, the green object, so they understand where we're starting from.
Okay, cool. Yeah, I just want
Yeah,
to
we're
put the
gonna
dots on that.
get to the point where there's a little character with its feet, and it's gonna have an animation running and jumping and stuff like that. It'll be cool and fun, and people will learn stuff from it.
Well,
The way I implement the jump is a impulse. So there's two kinds of basic forces in Corona. There is a force, which is a general force in a direction, and I'm talking about linear forces at this point. It basically a force that pushes on an object in a linear direction, which is what's keeping our white object pressed into the green object. But when I want to jump, I want to go in the opposite direction of the arrow. So what I do is I simply figure out the direction of my current gravity, and then I apply an instantaneous force, which is called an impulse in Corona. And I just apply a slight impulse, and then what it does is it gives like the player instantaneous momentum change in the opposite direction. It kicks it basically, or smacks it like a cue ball. Now, when you play around with this demo, the one that's coming out of today's Hangout, you're going to notice some issues. Issue number one, let me see if I can do it here. This has no concept of being on the ground, so I can jump, 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 jump. I can keep jumping, which is fine and cool and fun. In fact, I think people will go, hey, that's pretty cool. But the problem that would make this more fun is this has no what I call air control. Actually, it's a common phrase. So air control is what it means is when a character, like in a platforming game, is no longer on the platform, and you know how you can like move left and right while you're in the air? That's air control, the ability to continually adjust your character's position even though it's not touching anything. And so I have not implemented air control yet, and the reason is to implement air control correctly, I have to be able to detect when I'm touching something or not touching something, i.e. on a platform or not. And that code is simple, and the concept behind it is simple, but it would have obfuscated, made this current today, the gravity discussion more complex. So we will talk about a concept which is called a foot, where you give the object a sensor that can detect when it's touching something or on a platform. And we'll talk about how you implement air control in a radial situation like this when you're going around an object. Okay, so I've talked a lot, haven't looked at any really interesting code, and I'm just going to jump right into the gravity and explain how it works.
Although I will say I'm very excited about downloading this and playing with it, just for the sheer fact that when you made the character jump, the camera tracked the player momentarily until they came back to the shape, you know. So there's a lot of things going on there that I'm like, oh, I'm gonna dig into that and see what you're doing there.
Well, 99% of what you just saw going on can be found in the file that we're looking at now, which is
Sweet.
Playerlua. It's the builder for the player object. And the one bit of code that we're going to look at, let me find it, is, it's taking me a minute, I apologize. Here it is. Okay, so there's two functions that we use to calculate gravity, or to do this gravity business. The first of them is a function called calculate gravity, which is called, let me find it, which is called every frame. So I'm not going to go through this code right yet, but the player has a enter frame listener on it. In other words, that function executes every frame. Every time the next frame starts, it executes, and it gets to make some decisions, change the position of the character, etc., etc. And among those things it does is it calculates a distance to all of the pieces. So it says, white character, how far away are you from this, from this, from this, from this, etc., all these little blocks, and it sorts that table. So that's what the first function here, calculate distance to pieces, does. And then the next function says, all right, having now figured out the closest piece, let's calculate a gravity for the player. So let's look at calculate distances first. I talked about this already, but basically what it does is this function takes the first argument is the player, and the second argument is a table which contains a reference to all the other blocks in the game. So the table contains a reference to this block, this block, and so on. So there's 4 or 5 blocks in our current sample. So there's 4 or 5 entries in this table. And what it does is it just iterates over those entries, and it says subtract, using vector math, the position of the block from the position of the player, figure out how long that vector is that comes out of there, and then store that as a field on the block. So, for example, this block here, the green one, is 75 pixels away. The center of this object is 75 pixels away from the center of the white object. And then when I jump, the distance gets further. So you can see that the number goes up. But this 75 is the value that it's getting stored in distance to player, or dist to player, a field. So then, having iterated over each of these, you can ignore this debug code. The debug code is basically updating this little label, so we don't care about that right now. I've calculated these distances, and then I use a custom sorting function. So if you're familiar with Lua tables, you'll know that you can create your own function to implement a custom sort. So my sort function, compare, says return the object whose distance is less than the other object. So I've got object A and object B. So as I iterate over this list with table sort, it says, is object 1 closer? Does it have a smaller number than object 2? Okay, it stays in the front. No, object 2 is less? Swap those two. So then object 2 goes into object 1's position, and object... It's just like a sort of like a bubble sort, but probably not. Probably implemented much more efficiently. The point is at the end of this line here, our table containing the pieces will now be sorted by nearest to furthest from the player. So then we'll return from this function, and the table that we passed in will now be sorted, and we will pass it directly into another function called calculate my gravity. Find it. So this function takes a reference to the player and the table that contains all the pieces. And then what it does is it simply says, give me the first piece in the table. Take pieces number 1. If there's nothing then, if I've got nothing out of there, that means there's some kind of problem with the code, or the code isn't quite ready to start, it aborts. Because obviously we can't apply gravity if there's no place to apply gravity in the direction of. And then the next bit here, you can see this is an extremely short function. I should point out, I forgot to mention this, although I'm using SSK in this code, in this demo, I'm doing so because I knew that I was going to be way too lazy to do the longhand vector calculations. But what you see here is basically like 10 lines of code, this bit right here. This would be about 50 lines of code if I had longhand calculated all this stuff out. So I'm much too lazy, so I'll explain it line by line, and then you can simply take a look at the SSK code that goes behind it. Up here, first of all, line 123 to 126, I have localized some functions out of my Math2D library. So a vector scaling function, a function to subtract one vector from another, a function to normalize a vector, which is to take a vector and turn it into what's called a unit length 1 vector. So the length of the vector is 1, or a unit vector whose length is 1. And vector to angle, which basically takes a vector and converts it into an angle between 0 and 359.999 degrees. So, having the object that the player is nearest to, what we want to do in practice is to calculate a force that points in the direction from the center of our object to the object we're going to be attracted to. Now, we're not really attracted to this object. What's going on here is we are basically calculating a force and then applying it, and because it points right at the object we want to be attracted to, quote unquote, air quotes, you can't see them, it's just going to push it into it. This object here is static, it's not allowed to move. Our player is dynamic, and so the forces will be able to move our player in this direction. And then the physics engine says, good, I'll keep moving it until you touch it, and then I will stop that movement. So let's go back to the code. First, I recalculate the distance. I'm sorry, I extract the distance. So previously we calculated all the distances. So I extract the distance, and I may not even, oh, that's right. And the reason I extracted the distance is because originally what I was going to do was apply a scaled gravity. So I'm sorry if this is confusing, but let me stop for a minute. One thing that people need to realize is if we use the term gravity versus a force, we're thinking about a special kind of force. Gravity is a force that changes based on distance. So if you consider this to be zero distance, when the player is on the object, think of this player as us standing on the Earth, and the green object is the Earth. When we're at sea level, gravity is 1.0. So just one standard gravity for Earth. However, if we, I'm going to jump and pause here. At this point, if we jumped miles high, obviously, the Earth would no longer be pulling on our bodies with a 1.0 gravity. Gravity has diminished by the square of the distance between our physical center and the Earth's physical center. So, in a nutshell, the further away you get from an attracting body, the lower the force that gravity has on the body that it is attracting. They're both attracting each other, but if we simplify it and say that the green object is pulling on the white object, out here, if we're talking about gravity, the force is less than when we get right up next to the green object. Okay? So bearing that in mind, originally when I was going to make this example, I was going to embed that concept into gravity, into our personal gravity. But then I realized after I did the demo that I didn't need to. So we can take a vote after I finish discussing this, but I might throw in a feature where people can see the difference in how it feels with a gravity that diminishes versus a gravity that is always consistently one force. Okay, so the next step here is I create a vector by subtracting the position of the player from the position of the object that I'm trying to attract my player to. Then I take that vector and I convert it into a unit vector, so it's 1 in length. And the reason I need to do this is because I want to take the vector that was saying basically it points, it's a vector, how do I demonstrate this? Hopefully people understand what I mean when I say vector, but think of it as an arrow. There's an arrow pointing from the center of this body in the direction of the thing I want to be attracted to. This step here, line 134, I basically did a calculation that gave me that arrow. It's an X and Y pair that describes both direction and an amplitude or magnitude. But because I want to control the strength of the force, I need to get rid of the magnitude part. And so what I do is what's in math called normalizing. I normalize the vector. And what that means is I take the vector, no matter how long it is, 100, 500, and I keep the part that tells me what direction it's pointing in, but I change the vector so that it is a unit. It's a unit length. Its length is 1. So in other words, I can take that, its length is 1, and I know what direction it's pointing in, and then I can later use that information to turn it into a force vector by applying a magnitude. So if I want to push this object over here at 100 something, 100 gravities, let's call it, I would take a unit length vector and I would scale it by 100, and then it would be pushing my object with a 100 length vector in this direction. Okay, so I've got my vector normalized. One thing I need to know is I need to know what direction it's pointing in, and the reason I need to know that is because I want to apply that angle and rotate this arrow. This is a debug feature only. So I use vector to angle, and I extract the direction the vector is pointing in, which turns it into a simple angle between 0 and 360 degrees. Then I do a trick. So in Corona, actually Box 2D, when you apply a force to an object, if you apply a force of, let's say, 10 to an object with a mass of 1, and you apply the same force to an object with a mass of 10, the object with the larger mass is going to be less affected by the force because it's got more mass to move. Same amount of force, more mass to move. The second object doesn't move as fast. It doesn't get accelerated as much. So because I wanted to have consistent behavior in my game, I do what is called a mass aware calculation. So I know that I want to push my object with this field common gravity mag, which is just a number in common equal to 10. So I said I want to push it with a force of 10, but then, let me find the code, sorry. I don't know what the mass of my character is. I could decide later to make my character a little bit bigger or a little bit smaller, but I don't want that to change the mechanics of the game and like have put a lot of effort into getting the game to feel just right and then say, that character needs to be just a little bit smaller.
Yeah,
I make it a little bit smaller, and then suddenly my character's like jumping higher and moving faster. So what I do...
Ed, so what exactly is that going to make us do? I mean, math aside, what's the end result?
Okay, the end result is I make a circle this big, and I push on it with a known force. It moves a certain amount. Boom. See, it jumps out like that. But now, if I push it with a bigger force, let's just change the force. I'm sorry, that was my jump force, so that'd be... If I push it with a bigger force, it really jumps out.
Oh, so we get a much different result.
Right? So the problem here is the same thing can happen. I'm going to go back to my original. Now, I'm playing with the jump value and not the value for gravity, but it's the same concept. But now let's say that here I go, let's make my player 1/4 of the size. But the itty bitty guy. Do you see how it jumps out the same distance as it did previously? So
right.
No matter what size I make it, it's always going to jump out the same distance. Now the reason it's doing that is because I made a mass-aware calculation here, where I took the player's mass, and I took the number that I'm jumping by, or the gravity force, and I'm adjusting it by the mass. So the bigger the mass, the bigger the end force. The smaller the mass, the smaller the end force. And because these are linear, they change equally with each other, I can keep my game playing the same way and feeling the same way, even if I make micro adjustments to the size of my player. So example, let me show you what happens if I take the mass awareness off. So this is my mass aware code, and I'm going to take the mass part out of it, the mass calculation, reload it. Now, I made my character 4 times as small as it was previously. Now when I jump, it jumps much higher. Or if I make it super, super, super tiny, let's make my character like super tiny. Let's divide this by 10. Load it. Itty bitty guy. Now it jumps off into space, never to be seen again. So, a lesson here is if you want to avoid this problem, keep in mind the mass of your player. Then, as you go along and you make little tweaks to your game doesn't start playing differently. It always plays the same.
Okay, so you knew these things were going to be an issue.
I
So
knew that would be
you
a
had
problem
built it into the
from
calculation.
the get-go, so I just put the code in there.
Yeah. Otherwise, you wind up going in and tweaking individual variables and trying to get everything to feel right, and spend a lot of time doing that.
You spend all this time getting the game to go just right, and you're like, the character's a little too big. I'll make it smaller. No problem. Why is my game not playing the same anymore?
Right. Yeah. Yeah. It's the iterative part of game design that becomes a beating if you don't set it up right.
Exactly. So I'm doing a terrible job of describing it because I'm pausing too much here. Where's mass? So.
Well, it's hard to describe a calculation, right? Visually describe a calculation.
It is, and I'm struggling with the idea that, one, I'm probably not doing a proper job of giving you the mathematical terms, and two, maybe people don't have the math concepts, so I'm trying to sort of like twist it around and say an arrow pointing this direction that's this long. So because that's what these things are. When you look at them on paper and you go to school and your teacher says, here's a vector, they draw an arrow on the board. You're like, no, that's an arrow. That's not what's a vector? I don't know what a vector is. I know what an arrow is. So an arrow is just nothing more than a visual representation of something that points in a certain direction and has a certain length. And that is the definition of a vector. Points in a certain direction, has a certain length. And to do all these calculations for gravity, we need vectors, because vectors tell us how much does it go in the x direction, how much does it go in the y direction. Boom, apply that as a physics property, done. So we got the vector that tells us the direction that the force should be pushing the player. We have calculated the magnitude, which is how long the vector is going to be, how hard is it going to push on the player. And then we take our vector and we scale it. So we took our vector that was length of 1 and we made it the length of magnitude. And then we store that in a field called myGravity. So I have a tendency to do this in my games, in apps. I know that there's no field on display objects called myGravity, so I'm safe to store some data there. So I want to store the vector, which is a table, on the player to use it later. I'm going to calculate it here. I do it here in this nice little bit. You can separate this out and use it in your own code other places. But at the end of the day, all I've got is I've got my player object with a field called myGravity containing a vector which describes a force pointing in a certain direction with a certain magnitude or a certain strength. Then later in the code, remember how I said every frame we do this? So we calculated the distances, we calculated the gravity. And then the very next step is I simply say apply force to self, which is the player, and apply it in myGravity x direction, myGravity y direction. Sorry, it's highlighting. And apply it at the center of the body. So in other words, let me change the size of my player so we can actually see that guy again. We got our player, we got this vector pointing down, we got a force that we calculated out of that vector, and I'm saying is in the middle of the object, apply a force that points in this direction. And that when I unpause the game, will cause our object to move in that direction. And that is the essence of a localized gravity. I faked it. Basically, I said, I know the effect that I want. How do I get it? Well, I apply a force to my object to replace traditional gravity, which is a thing in Corona, or in Box 2D, with my own personal gravity thingy, a localized force.
It seems like a lot of game development turns out to be that, right? When you see something, you're like, how did they accomplish that? Right? Like we were talking on the other day about creating puzzle pieces and having them snap together and all that kind of stuff. And then when you start digging into the details, you're like, oh, that's an illusion, or that's a you
99% of game development is illusions.
Right.
Really, what it is it's like I described early on. You have an idea, or you see something that you want to do that somebody else has done, and you want to experiment and try it. You say, what are the tools that I have in my toolbox? How do I know to do these generic things, and how can I take those generic things and combine them into an end result that does the same thing? I guarantee you that these guys probably, or guarantee, I'm not sure which now, did not use gravity to do this, because there's some issues with using gravity to implement this game. But we're not going to go there today. There are some things. Let me show you one little thing. You see this guy right here? See how he's wobbling around on the square bit?
Yeah.
So I can rock him around like that.
Yeah, right.
Why does it do that? Because it's a square, but the force is always trying to push this right into the middle. So the further out on the edge you get, then there gets to be what's called a torque, because it's trying its dangdest. I was going to say another word. It's trying its darndest to get this white object into the center here. But the object itself is pushing back because it's got a physical body.
Yeah, and as you go out to the corner, you get farther and farther away from the center point, right?
Yeah, you get further from the center point, but then it compensates because it says, well, shoot, if I can't go there, I'll try to get you closer, and it pushes it this way. A torque.
Mm-hmm.
Because there is a moment of inertia there. There's an arm. There is a lever effect. And you're like, okay, everybody said, what? I don't know what you're talking about now.
Well,
so
cool.
we'll talk about how to fix that problem later.
All right, good.
Okay, so before I know we're past,
Okay.
I just want to reiterate, no error control. You can jump numerous times. We have not applied the art yet. We're gonna fix these things in a later Hangout. But the essence of today's show was the player calculates the distance. What we do is we calculate the distance from the player to all the objects we want to be possibly attracted to. We find the nearest object. Then we do a number of vector calculations to create a force vector, and then we apply that force vector in the middle of the player in the direction we want it to go, and the physics engine takes over and does the rest. When it hits the body, it stops. It's really, literally that simple.
Good. Okay. That feels like a good place to stop then. So let's do that, and we'll look at the rest of it moving forward. We'll do that next week. So
I encourage people to download the code and play with it.
Yeah, basically, that's what you should be doing at this point: is download it and break it.
Yeah, I'm sure you'll find bugs, but
no, well, I mean, just like go in and adjust the variables like you were doing. You know, go in and see what
I want
things
to show
do.
people one more cool feature. I'm sorry, I got to do this. I forgot I wanted to do this. So one thing when you're laying out your levels, you're like, I really can't. I don't want to play the level every time to see the layout. So I made these little variables at the top, which are level grid, button size, block size, etc. And if you want to see the whole layout, what you can do is simply do this. Multiply the gap size by 1/4 or 1/2. Just go into line 24, change it, and reload it. And
We're still seeing you, by the way. I'm still seeing your face. I mean, if you're showing us something, that's cool.
Oh, yeah, my face. I'm sorry. Let's try that again. Okay. So on line in common.lua, let me back up here. You want to see your whole level. Well, an 8x8 grid's not going to fit on the screen. So what you do is you multiply the block size by 1/2, and then actually I'm going to leave this bit off because everything is kind of related to the block size. See how the block size is used to calculate the player size and the gap size? So if you make the block size 1/2 of its normal size, and then you reload the game, the whole grid gets smaller, and all the pieces get smaller. So now you can see them all. And you can so on and so forth, make it even smaller. And now you can do a whole layout and see the whole 8x8 grid, and you're like, that's the layout I was looking for. Instead of playing through every time when you're making your levels using level 1 Lua. So that's just what you're seeing here, but obviously more visually attractive here because you can kind of see how it's laid out.
Oh, cool. So that makes me think of, you know, like having a peek feature, you know, where you can like kind of peek over to the next piece and see, so like you've got those controls at the bottom, the D-pad controls at the bottom and stuff, and then if you had like a peek button, you could hit the peek, and you could like maybe peek to the left, peek to the right.
Now, I was gonna give a button because like zoom in and out,
Mm-hmm.
but then I'm like, I can just multiply by 1/4 and you're done.
Right. But those are in-app purchases. You want to buy some more peaks?
Yeah. In-app purchases. What am I thinking? Monetize.
Earn peaks.
There's
There's that monetize again. Yeah. All right. Well, cool. And Brian, you said you got some similar examples beginning in the beginning mobile app development textbook.
Well, when that's referencing back to what Ed was talking about at the beginning for designing the levels. I did something similar with my Rotten Apples example of the flow of enemies onto the screen. So completely different type of game, but yes, there's a similar example of using an array or a field to control the flow of the game.
Okay, cool. All right. Well, there you go, guys. I think that's a good place for us to stop. We've got a lot of stuff we want to cover in the next show, so be sure to check the show notes. We'll have links to this. You can download it, play with it, and then come back with questions. Let us know what you have, things that you want us to explain a little more or unpack or whatever, and then we'll have more for you next week. So be back here next Monday at 12 p.m. Pacific to talk all about mobile app development. And until then, have a great week and happy coding.
Auf Wiedersehen.